All right. Good morning, everyone. Hopefully you can all hear me. If not, please post in the chat if you can't hear me. My name is Jason Koo. I am a developer advocate here at Neo4j, and I am filling in for Alexander Ertl. And I am joined by a very special guest and a good friend of mine who used to be a software developer at both Google and Microsoft, and is now the founder and CEO of Boundary, Vaibhav Gupta. Vaibhav, can you tell the crowd a little bit about yourself?
Yeah, thanks for having me, Jason. Always fun to chat with you. And any excuse I get is one I'll take. But for everyone else, I'm the co-founder of Boundary, as Jason said. Before that, I worked on HoloLens and a few other AR technology at Microsoft. I was in the original team that started that. And then I went on to work on Face ID and augmented tech at Google and worked at a hedge fund for a while as well. And eventually I decided I wanted to do something a little bit more fun. And I started this venture with a good friend of mine, Aaron, to go and start Boundary. And our whole goal with Boundary is to help people build systems with LLMs that are actually reliable and can do things that I think people today don't even know LLMs are capable of doing.
Yeah, well, kind of riffing off that. So what do you think is kind of like what most people do think of what LLMs can do? So that
I think most people think that LLMs are really good chat applications, and you can talk to it and you can ask it questions and you build an amazing chat GPT. But I think they don't realize that you can build reliable applications off of machine learning models. And that's really the missing gap. I think when we first chatted, I remember showing you something that you found a little surprising. And I think everyone else, just to like set the pace for what I think LLMs can do and have everyone else come to the same page, maybe we should show that to everyone else.
Yes, yeah, right. Because let's start with that. So just a little background. So Vaibhav and me, we met, I think it was at AI Engineers Fair.
Yeah, it's like,
no, one of the
maybe
conferences.
a Zoom event, an event over at one of the conferences. Actually, yes.
Yeah, it was on the waterfront in San Francisco, and I was just walking around, and at first, like I didn't think there was like any sort of connection between what you were working on and us at Neo4j, but you were super excited. I was like, okay, there's something on the screen happening, so I stopped and I chatted with you, and you were just like, oh yeah, we could totally do graphs. And I was like, oh, all right, let's talk. But yeah, to what you mentioned earlier, right? Like, so LLMs, a big problem with it in production or in enterprise solutions is A, hallucinations, and two, having to kind of coerce data from an LLM to something usable, right? A JSON structure, some sort of structured data to make use of. So yeah, Vaibhav, why don't you show us what you showed me or something akin to it?
So just to set the pace, what we do at our company is we make a programming language or an AI framework called BAML. And the whole point of it is to add reliability. It's like React. React added a lot of reliability, so we don't have to write JSON, plain HTML and JavaScript. BAML adds reliability, so you don't have to write plain strings, and you can get models to do really incredible things. So I'll use one example. Like in this case, I don't even know. There's like some circuit, some diagram of some kind. And what we can do is 0 shot, no prompting needed. What we'll do is we'll have the model start describing to us BAML code. So the model in this case is generating a BAML schema that describes that image, and then we're running the BAML schema.
Vaibhav, are you showing your screen?
Oh, yes. Are you not seeing it?
Okay. Yeah, I'm not seeing it. Hold on. Let's see if...
Let's try again. I think I have a source that I just added, actually. And then I think you have to just promote it. Let's do that.
Okay. Hold on. Let's see if got this option here.
There we go.
All right. Cool.
So I'll start again from scratch. So what we have here is like a random image of some kind, or we can use like even like a screenshot of like a log file that we all might have seen for a while. And this log file is nice, and we could write a bunch of parsers on it, but we can also use LLMs to turn this log file into something a lot more structured and magical, even though it's an image. So what we're going to do here is a 2-step process. The first step is we're going to have the LLM generate BAML code that represents this image, and then we're going to run that BAML code. And now you can see what it's doing. It's actually able to pull out all the metadata about this image and a lot more down here, as you can tell. For different types of messages that come in, they get different kinds of content attached to them. And we're able to just turn that into something from which was unstructured completely in the form of pixels, and something that is structured and now can be navigated in a database where I can say now search for everything where the timestamp is within a certain time. So building a graph relationship out of this suddenly becomes a lot easier. If I want to take something totally random, like a visa form from Cambodia, and imagine I'm processing millions of these because I'm the Kingdom of Cambodia, then you can do the same thing over here, where what we do is, give me one second, I'll just rerun this one because that one is a long image. And you can start seeing what this can do. Once again, we're going to take this content, we're going to describe it using BAML, and you can handwrite this schema, or you can have the model generate it. In this case, the model generates it. And then we just execute that code. And when we execute that code, we get something a lot more reliable. So I'll show you something that I found really surprising. See this thing over here where it says the first trip to Cambodia? This has suddenly become a true rather than the checkboxes that we had available over here. So again, as you process more visas about the same person, you can build graph relationships about entities and say that this person is an entity who was applied to Cambodia using this form. I can show a lot more of these demos. You can do it with almost anything. I can even, let's see if I can do it. Sometimes this works. Let's see. My dog's here. So let's see if we can get to describe me and my dog. And I'll hold an expo marker while I'm at it. Nico, sorry. And right there, you can see that it's going to go ahead and extract the data out of it. It's able to detect I'm wearing glasses. My shirt is black. I've got a dog. It is a multi-poo. So that's kind of funny. They even got that it's a multi-poodle. And you can see how we can turn this into not just outputting this schema, but really graph schemas as well, as I'm excited to get into later today. So I'll pause here for a second.
This is, I mean, yes. So if anyone has questions, please post in the chat and we'll answer them. So normally when I'm working with BAML, I build all the models by hand, right? So I know what the output is going to be. So what is, how do people activate the self-model generating feature?
You honestly just ask the model to generate BAML schemas. So I think the easiest way to do it is we have a prompt that you can use, and then you can just leverage that out. It's the same thing that powers, like I think today we wanted to discover, like, let's say we want to build a graph relationship off of, I have users that are going to give me a long list of movies and their content and actors, and I want to build a graph data out of it. How would I approach this problem today? This is just an example. We can, someone asked, like, why do we use like images, not text? You can use any sort of medium you want: image, text, audio, video, PDF, anything you want. It will work. But let's try and do something a little bit more interesting where we want to generate movie databases. So I have a list of movies and release dates, actors, summaries. I want to create a Cytos graph, or what is it called?
Oh, Cytoscape. So Cytoscape is a JS library for visualizing graph data. So it's one of several.
Oh, sure.
And they have a particular JSON format for reading.
Yeah. So in this case, we're going to do the same thing. I'm gonna tell the LLM I have a bunch of these, and I want to convert it to a Cytoscape structure for it to represent. To push it into a graph database. So this isn't really me like giving it too much instruction, but I tried to be very, very light. And it's just going to go ahead and just take this content that I have right off the bat and start describing this in BAML code. And I'll show everyone in a second like the full end-to-end workflow, because I think that's going to help clear out some of these questions.
Okay, perfect. Yeah, because Prashant had a question of how the LLMs generate the BAML models.
Yeah, so in this case, I have the LLM generating all the BAML code, and just to play around with this a little bit better, what I'm going to do is I'm actually going to move it right over into VS Code and Cursor, something that we're all a little bit more familiar with than these UIs. Give me 1 second. Okay, and then I'm going to screen share my other screen. Okay. So let me just describe what happened here. So what I did is I described to the model what I have, which is a bunch of movies and a bunch of actors and some content about them. And what I want to produce is I want to produce some sort of graph structure about these movies and these actors. So in this case, I asked, what I have here is I have a function where it's going to create a cytoscrape graph. Then I have in here, I'm going to pass in a bunch of movies and pass in a bunch of actors. And I'm going to ask it to produce a graph data structure. The graph data structure will have movies and actor nodes. And I guess this should actually be, that's the wrong thing. This should be a movie and actor node like this, where I'll have a bunch of nodes, which are either movie nodes or actor nodes. And then I'll also have a bunch of edges, and the edges will inform the source, the target, and then the relationship that they have in here with them. And then I'm just going to dump all the data into here, and I'm going to let BAML do this. Now, what else I have is I have some test cases. So in this case, I have movies, very, very simple one, where I have the matrix, genre, summary, and then obviously the actor, Keanu Reeves, who's amazing. And then I have some other slightly longer ones where I acted 2 test cases. Now, what is BAML doing here? So the first thing that I can do is I can actually go ahead and just see my full prompt as is. And I can actually see the raw web review that's going to go out to the model under the hood. I can see the tokens that are being passed through. And then, but I think the most important thing is I can actually run my test cases. So I can see what happened. In this scenario, the maze tricks, the model produced some data. And it had some backticks in it. It had some other nodes, but it actually produced, what BAML did is it converted it from this raw string the model gives into the data model that I enforced. So in this case, the data model has to be a graph structure. So I have a bunch of nodes, and I have edges coming back out of it. And it will always guarantee that it's going to be that specific data model. So if we do things like do not use quotes around keys, I want you to pay attention to how many tokens this costs. This costs 316 input and 124 output tokens. If I run the same thing, I just went down to 109 output tokens. So that's 109 divided by 129. That's just like 15% cheaper and faster for free. And the reason is we just got rid of all these quotation marks around all these values, but we still converted it to the right data model that is actually compliant and usable in the rest of your code base without you having to think about it. And then you can do things like before answering, note any other facts you may know about the movies that may help. Let's see if we can do this. Example. And I'll add some chain of thought into here. Oops. Schema. Oops.
So here you're asking the LLM to draw from any of its training data to add
Never.
to.
Yeah, I'm just like let's just see what other facts that might help other actors, etc. And like let's just see what it does. That's kind of interesting. And you can see how I was able to draw from the training data, and it was able to go add metadata into here automatically by leveraging chain of thought in the model without really using the chain of thought model. And now my data is slightly more populated by the data it had. And we can go the other way where it can say, and you can see how just this iteration loop that we had is a little bit faster than if I had to go and like prompt it somehow and write unit tests and just iterate very quickly.
Right. Very cool. Oh, so we had a question that was answered in chat, but I'm going to post it up here for anyone who's not following the chat. So was asked, is BAML open source?
Yes, BAML is completely open source. It's open source and built in Rust. So if you get started, getting started is just adding a couple BAML files and downloading the BAML VS Code extension. And then eventually when you do that, you can actually open like a Python file, demo.py, and you get to do something. So now that we have this graph data, maybe we can try putting into a Neo4j database if you have one on the fly. What we can do is we can do from BAML client import B, and then you get graph equals B dot, and we have a function here called create cytoscrape graph. create cytoscape graph. So it autocompletes. It's going to be a list of movies. So let's add in a list of movies. And it's able to autocomplete because the system even cursor knows the types here, because if you type in the wrong type, it'll actually yell at you. So cursor is able to use the language server to go get good data here. So like if I suddenly like, let me do this. This is a list of movie nodes. Did I turn on strict typing in Python? 1 second. It's on. I'll turn on. Yes. So it starts yelling at you as soon as you turn it on. It's because this is a strict and we need a movie node in here. So how do we do that? We just, from BAML client, I'll just let cursor do the magic that it needs to do, so I don't have to do anything. And this is yelling because I'm missing genre. Boom. And now graph is guaranteed, no matter what, to be a, do I need to do a wait? I'll do a sync client really fast, so I don't have to do a wait. Graph, no matter what, is guaranteed to be a graph data structure. So if I do graph dot edges, edges are guaranteed to be a list of edge info for edge in, print edge dot source, right there. And if you suddenly changed source to be a string array instead, source in Python ends up being a list of strings. Change it back, it's go back to being a string. And this kind of keeps your types completely safe from what the model sees and what you see without having to worry about any abstraction layers around it.
Nice. I'll post a link to a sample project I did, which just takes the cytoscape data and pushes it to a Neo4j database. It's fairly, it's fairly trivial. I even have a gist, and you can ask any LLM like, hey, take cytoscape standard format and write Cypher statements for pushing that up. So I'll post it in a second. In the moment, right now, so we did get a very challenging question, one that I'm not sure what the answer is, but if, say, someone has a ontology for a very strict directed acrylic graph where the relationships have to go in a particular direction, is there a way to enforce that in BAML?
There actually is. It depends on what kind of relationships you're talking about, but we have, I think the easiest way to do it is, one huge problem that you have when you're creating any sort of graph data is you need to normalize names. For example, like we get like you have a contract, you're analyzing it, someone used the word Microsoft, they use Microsoft Inc., they use Entity One. How do you like standardize that sort of name? And then how do you build those relationships in a way where like we all recognize that all of these point to the same thing, which is in our standard database called Microsoft Inc., but is called Entity One or Company A. In the graph database, you can do a variety of things. But let's see if I can screen share again. I think the way we like to look at it as a very high level is, in the end, all these things are just code. And what it really comes down to is the way we write the code has to support.
Oh, hold on, Vaibhav. I'm not able to show your screen again.
Oh, I'll share it in a second. I haven't shared it yet.
All right. And while you do that, I'll post a link to my GitHub that has a sample BAML cytoscape to Neo4j fast API server example. Yeah,
and I think before I show the demo of how you write it, I just want to show everyone like a concept that I think is useful to think about when you think about code. BAML is not doing anything magical. BAML is really just a syntax that just takes your code and executes it. Like Python is a syntax that makes you not have to think about memory management and writing C code. You just write Python. C is a syntax that makes you not have to write assembly. It just makes your life easier. So when I think about it, like it really boils down to this premise of like, if API calls fail 5% of the time, your database fails, you like shut down your company and you fix it right away. If LLMs call, we're all like surprised. And our whole theory is like, that's not okay. Like that's not the way you should be writing software. And it goes back to the way we used to write websites. Many of you might have written a website like this a long time ago. And eventually we all realized this is wrong and we should never do this. And we should fire anyone that does continue to do this so we can write websites like this instead. And fundamentally, the browser still needs to see HTML, but it's important that you can actually like really quickly say that if this count variable, if this is called re-render this component, I don't have to think about it. It just does it for me. The syntax expresses that idea. And really the difference is like you go from a world where you have a lot of strings, managing state was very, very hard to go do in the old world of writing plain HTML, and reusable components were hard. And most importantly, that people overlook is the iteration loop. When you broke something, you were like, I don't know which string I broke that broke my website. But React just yells at you before you even hit Command S that this is not correct. And that whole process is just the ability to add engineering rigor. And when you look at like agents, I see a lot of people write prompts like this. I don't know if any of you have written a prompt like this before. Jason, have you?
Maybe.
And it's not that this is bad. It's just that this is just, it's the same problems that you had before. You have a bunch of strings, managing context is so hard. A new model comes out, R1 came out, and now all of a sudden you can't use it because your system is hard-coded to OpenAI somewhere. And if you change that setting, it changes your whole pipeline, not the one thing where you want to use R1. Like by the time you test your prompt, you've spent 40 minutes trying to figure out how to isolate that one prompt out of it and how to get all the data coming in from it. It's the same thing, just low engineering rigor. And like almost every framework that you have out there, we've all seen these, has like one huge problem. Like you can't even see the prompt. That's like writing a website without seeing the HTML code. So in this case, where we want to go ahead and say, we want to like add some relationships on this, let's take a problem of like, I have like a resume prompt here. And let's say I want to guarantee that the email is not a Gmail email. So no matter what happens, I don't want this to be a Gmail email. Let's like write some things on here. So what we can say is we can tell LLM, don't be a Gmail, that's funny, email address. And what we can do is we can go and try and run this test case and we can see what it does. And the LLM doesn't listen. And I can confirm that I actually sent in there, I said, don't do that. I don't care about Gmail addresses. Let's see what it does. And now it listened, but there's no guarantee it's going to listen. And that's the point. So how can we do this? We can just do this. Type non-Gmail email equals string. But we can add an assert attached to this and say that at gmail.com, not in this. So this has become a non-Gmail email. So we don't really change the prompt here. The prompt is the same as before, but we do enforce that if the model does somehow spit out a Gmail email address, then it will ignore it. So when I run this, it'll do a couple of things. And the first thing we'll do is now we have to acknowledge that, hey, in some cases, we're going to only get Gmail email addresses. So let's make this optional. So when it only has Gmail email addresses, we allow for null values. Let's run this. And in this case, the model listened. I'll run it like 2 more times because models are weird. So you can see here, even though the model dumped out VBV at gmail.com, we converted it to a null because this doesn't meet the constraint that you enforced on this string, which is it cannot be a Gmail email. So it's a blend of combining a model with the benefit of guaranteed algorithms, which may not be as flexible, but might be important to encode into your data schema at some time. So you can do this with ontological relationships as well. I don't know if that answers the question.
Well, to see in chat, I think it does. Reinforcing like particular relationships will be interesting too, and you can also kind of enforce that on like the Neo4j side, right? So you
exactly. So there's different ways you can do this. You can enforce it in there, or you can say like, oh, what I will do is I will take my Python code that I got this data on and run post process on this to make sure it's valid. And if it's not valid, I'll actually go ahead and run it back against the model and try again, and have the model fix a mistake for myself.
We had an earlier question from Prashant when we were talking, or when you were introducing using the LLM's own training data, and kind of an opinion piece, but probably worth addressing. Is he said relying on the model's memorization to produce new data sounds like a recipe for hallucination when the data is out of domain. Any thoughts?
That's funny. Someone mentioned about the screen thing, but yes, I do agree that that can be risky, and that's a really, really good point about how hallucinations might come up. But let's think about what a word hallucination really means. And I think this is what people get wrong. So like when we built Face ID over at Google, a lot of people assume Face ID is a single model, even at Apple. Most of these things are models plus algorithms. And I'll give you an intuition about why. You probably do want to use a model to decide if a face is the right face or not. But you probably don't want to use a model to necessarily always say, I mean, maybe now you do for this problem, but to necessarily say like how many millimeters apart are the two eyes? That's not a really good way to use a model. You want to do that with math, especially once you detect where the eyes are. Perhaps using a model, the distance can be computed using math. Now, similarly, you can also do this with like the positions of faces. When I'm in this image, my face is about like 1.5 feet away from the camera. If I go here, my face is very different. Before feeding the data into the model, I might benefit from standardizing the face. And I can do that with math, once again. So there's different benefits of how you can marry what I call like models are these beautifully flexible creatures that are horribly inconsistent. And I was trying to find a nice word to put it, but and then models are and then algorithms are these beautiful things that are really consistent, but it's horrifically non-general. But if you marry the two together in the right way, you get something that is really flexible and really generalizable. And I think when it comes to hallucinations, the same thing. If you want to hallucinate, the model does have a lot of knowledge. Sometimes the user is wrong when they ask you a question. They just don't know, and the model does know that. I've done this. We all have seen this in our code. The model sometimes does write better code than us. Not always, but sometimes. And it's sometimes useful for it to be able to disagree with us and just give us more information, or perhaps even just say that our information is wrong and replace our information. So the source of truth is really varied in these situations. And if I could instead say, let's say that problem where we have about where the hallucinations are coming from, Prashant asked, is how could we make this better? Well, we can take this code in BAML and we can say, I want to know the source of the relationship. Type from data from inferred. Let's just see what this does now. So it did list out some actors. It did start saying things, and it started telling me things. So this is from the data. It didn't really understand what from data means. Let's call it original data knowledge baked. I don't know. Let's see what it does. And again, you're just watching me iterate really fast. So this is just live and seeing what it's doing. And we can just add a description. Add description. Baked knowledge from the from your thoughts. Relationship was provided from the user. Let's try running this one more time. And now you can see over here that I'm able to actually get that Keanu Reeves acted in the matrix from my original data. And these came in from the baked knowledge the model did. So how could I de-risk this? I can just have the model can tell me where it's coming from. But for anything where it is original data, I can literally just enforce that Keanu Reeves is in my actors node that I provided the model. And therefore, I know it comes in from my original data. I can know that this relationship came from here. And this is kind of the way that we've seen kind of marry the two together, as opposed to like have to fight the LLM. Let it allow it to make up data. And then in your UIs and in your data models, represent that certain things are baked in and certain things are known, and how you show them in the UI and your data models can like correct for that.
Nice, very cool. Oh, okay, we got a very dense question here. Let's see if this even fits on screen here. Okay, let's say you are creating an AI model that is solving math problems. You have a set of math problems and the steps to solve the problem in this data set. Can we use BAML to break the subunits of each problems based on inputs and outputs? So that, okay, so it cuts out here. So that we can, AI model can link up these steps to solve the problem. How would you demo this use case? Woof, okay.
That's really, sorry, I keep turning off my screen share. I guess I'll just leave it on. Let's just try it. I don't know. And I think that's kind of scary if this works. So the first thing I'm going to have a problem do is I'm going to decompose a math problem into it. So in this case, it's going to decompose the math problem into a sequence of steps. It's going to tell me the final answer, and then it's going to tell me what type of problem type it is. And each step has a description, an operation that it has to do, and then the result that it should have. And it actually made 2 test cases for me. One about like solve for X, and then another one that's just like a word problem that's very easy, I guess. So we can first see what this would do. And you can see that this seems to have solved for X in a pretty good way. Oh, I did solve for X. Algebraic. Let me run the basic one. The basic one is if John has 15 apples, gives away 1/3 of them, and gets 6 more, what happens? And it just starts and just starts working its way down and builds these steps out. And then how would you turn this into something more useful? Well, you could do it in Python. And this just calls the problem and just displays this sequence to the user in this sense. But we can build a UI around it. We can build interactive solutions in TypeScript or JavaScript as well. And this is kind of probably a similar. Does this answer the question of how you would do this? And I can share this in the chat for those that want to have this link.
Yeah, some folks were asking about where to find the code to implement something like this.
Yes. How do I post the chat?
So there's a button on the right for, oh, yes, there.
I don't think I see it, but I'll send it to you and maybe you can post it.
Okay, I will copy and paste into the chat.
Yeah. And I'll post the Neo4j code that I have as well. I think the coolest thing that I was actually playing around with Jason, once Jason started showing me some of the databases that we have, I started seeing something that I thought was really cool. So I built a small little app where I can ask it any questions about the movies database. And I was really fascinated by what I was able to do. I sadly didn't get around to building like a UI around it. And I think this starts to show the power of graph databases when you have them. So let's say I want to ask what's the oldest, what movies has, I don't know, a Brad Pitt been in with Brad. Been with who's an actor that Brad Pitt acts with?
Oh, I don't
know.
He was in Wolves. Oh my goodness, the other famous guy on Apple TV.
Let's just do Keanu with Neo. And in this case, this isn't really a query, so I want to show you what's going on behind the scenes. So what's going on behind the scenes is the first thing that it's doing is the agent decides what it has to do. And the first thing it decides that it wants to run a query. So it runs this query. And then it went ahead and yielded result empty, and it's able to actually tell me that there are no movies in the database that feature Brad Pitt and Keanu Reeves. So let's try been in that were released in 2020s.
Oh, George Clooney was who I was thinking of.
Yeah. And once again, it's actually able to build this query out for me, where it's actually able to say, and the movie was released in 2001, and was released after 2021. It says there are no movies in the database that is on this. Let's try again. Sorry, 1990s. He's definitely been in movies in the 1990s. One of my favorite movies, Fight Club. And you can see it's actually able to build, again, the query for me correctly. So we run this, we pull out the data out of the model, and the model is actually able to respond with something kind of nice, which is Brad Pitt appeared in movies, and each of these movies for me. And these are all backed by the actual database under the hood. But when I think about this, there's a couple of things that I did in this pipeline. So the AI part, I think, is the easiest part. The hardest part is actually not AI often. It actually ends up being, the hardest part that we see ends up being is actually building the agentic pipeline around this. So I had to do a couple of things to make this work for pretty reliably. But the first thing I had to do was obviously I do tool calling, and I decide if it's calling a graph query or just returning a response to a user. But in the case of a graph query, two interesting things happen. One, the model will sometimes get the query wrong because it didn't actually know the schema of the database. So the way I solved that was I actually just asked Neo4j to describe the schema of the graph structure using call DB visualization schema. And I just fed this whole thing into the model. I didn't even try too hard. But even then, it would sometimes get the query wrong because models aren't perfect. So what I had to do was whenever it got the query wrong, I appended a message that's specifically added error running the query. I add the query and I paste the error in there. And it would try again in this loop. And once it got it right, I actually got rid of all these error messages and only added the right query and the right response to the content and to the context window. And that does two things. One, it keeps my context window small. It's really important that I be able to keep my context window small because as I have a longer and longer conversation, I don't really care that the query was wrong halfway through. I kind of want to prune that out. And eventually, as the conversation gets to a close, I want to really just keep like the meat of the details in there. So I might even make the claim that I don't even need the query. I can just put the response in there. I did put the query in there just for context, but I think I could even get rid of this and it would work even better along the way and only put the results into the model itself. But I think one big mistake a lot of people make is they don't think about this idea of my messages and my messages array and my state buffer being pruned to only the most relevant context. And this really helped in this scenario.
Right. Nice. Now, is there, I'm assuming, I think because this was done fairly quickly, is there a chance that particular code could possibly get stuck in a loop if the query just, the database just doesn't have the answer for that type of query?
Yes, it can happen. And I actually have hacks around this that I do. And I think these are things that people have to go build because these loops are so how do I describe it? I'm going to screen share again, sorry. Here's what I do. So I say like, I start doing things.
Okay, try sharing again.
Okay, let's try again. I think it says I'm sharing.
Oh, it's not showing up here.
And while you're setting that up, Prashant asked like, what's the default LLM being used to generate BAML models in the background? We actually swap around. Sometimes we use Claude, sometimes we use GPT-4o. Honestly, I don't think the models matter. My opinion is even GPT-3.5 is really, really, really good. I think the point that a lot of people get where it starts to mess up is when they don't really frame the problem well to the model. So as we, let's press share again while we do this.
Yeah, try canceling the screen share and then again. Yep, there we go.
As we actually go ahead and get models to go do more things, and I'll show you like benchmarks on this too. The point is like if you ask a model to do 50,000 things at once, it will get it wrong. If the success of the model depends on the model outputting perfect quotes with if the success of the model is like, let's say I had to go output code where I want to do like a hello world kind of thing. In my opinion, this is, this block that I wrote over here is way easier for the model and a human to output than this block that I'm about to write over here. Actually, I'll do it. I have to escape these quotes because, of course, I'm in escape world. And like this is just, I as a human would have a hard time reading or writing this. So it makes sense that a model has to have a hard time outputting these tokens exactly. But if a model could output something a lot more flexibly, it becomes a lot more capable because it doesn't make the same, it's not forced into like making the same mistakes. And this is just like small things that we've noticed about why the existing, even like GPT-3.5 is really, really good. But as we go on with this, you ask like, how would you get around this loop? So what happens if like this is a while true loop and this is basically a money printer? I would like to not have a money printer. So I do a couple of things. So we know overage is only going to have data in it anytime the query is out there. So I can do a couple of things and say, if len overage is greater than 4. So I've tried 4 different queries. I literally can just do all messages dot append. This is really, really, really hard, obviously. Please. Try thinking what could be wrong first, then answer. And if you can't, just tell the user that this is impossible. And you can do things like this. And this is really simple. But now I've basically aborted out of the loop without really aborting out of the loop. And I can hard code this too, where I can say max iterations. And then I can come back and say, if len all message overage is equal to 10, then I can just return to the user hard-coded, I'm sorry, I can't help with that. So you can see I can handle these scenarios with software and engineering principles in a way that's a little bit easier and still allows me to maintain the flexibility of the model. I think it's about that. How do we let the model be flexible, but still allow us to have structure and control over these pipelines?
Right. It's about combining the two, right? Like you had mentioned before, rather than leaning on the LLMs entirely for all the reasoning and execution.
And also not leaning purely on the algorithm. If I had to really hard code this and stop my model over here, I'm actually benefiting from the model's flexibility here as well by letting the model be flexible and say, like, just try thinking what could be wrong first. And like, this is dumb, but it works. Models can do this. But it's possible the user asks something that's genuinely just too hard. So like, let's just put a cap on how much we'll spend on this and just like cap it here. And we can choose these caps and configurations based on our system's needs. And one thing you'll notice that I did is something a little nuanced here is I didn't actually add this into the messages array. I add this to the end and the most recent message every single time. So once I add it once and the loop resets with another failed query, this doesn't go in there twice. It only goes in there once. And it's the most recent message. And that nuance is something that is, I think, again, worth capturing. Because if we just build this and just keep adding this 7 different times, it doesn't help the model.
Right. It may even confuse it, right?
Exactly. Exactly. So it's like these small details that we've seen that really enhance the ability of the pipeline. And that's why like that demo that I showed you at the beginning where I'm actually able to reliably like run these systems on almost any question is not because like I don't actually know if it'll work. But it's the fact that we have systems like that in place in the back end that help us reliably generate this code. And then it also helps that we actually have a static analyzer that can give us these errors. And then we can kind of solve for these programmatically because BAML outputs very, very nice errors. Like feeding this to a model, it knows what to do to fix this problem without it even having to think about it.
Super cool. Awesome. No, I think we went through this kind of fast at the beginning, but for anyone who might have shown up after, Vaibhav, can you walk the audience real briefly through how they can get started with BAML?
Yeah, let me do that really fast. The number one thing, I keep forgetting. I'm so used to turning off screen share, so I apologize once again. I'll make the request one more time. Let's say we just have a new, one of the nice things about BAML is BAML works with any programming language, so it doesn't matter what language you want to use. You can check out our GitHub repo, and I'll link you to the specific link for the language. It supports Python, TypeScript, Ruby, Java, Go, C++, anything. And the way it works is, let's just make a new project. I think that's the easiest way to show you. cd repos. That is my projects folder of infinitely incomplete projects. Make dir super demo. cd super demo. Oops. Clear. And all you do is this command. You do uv init or poetry init, make a Pi project, virtual env, whatever you want. Clear ls, and you can see I have a few BAML files. I have a Python file. Then you just do uv add BAML-py. Clear. uv run BAML-CLI init. And these are all documented on our docs. And then open this in VS Code. And you end up with BAML files that are already there for you. You can, this is going to yell at me to update my version because I have not, BAML just updated. We sent out an update last night. And we actually help you manage versions as well. So that way you don't accidentally end up in sync and we don't accidentally ship a breaking change to you that can break your product. And then once you're ready to go, you just start in here and you have at the playground, you can set your API keys right in the VS Code playground. So it's a complete sandbox, runs completely locally on your own machine, no remote calls. Even the algorithm that I'm running here to do like error correction on the model is running completely locally in a couple of seconds. So no remote dependencies. You can configure what models you want to use, OpenAI, Gemini, GPT, add retry policies, anything you want. And then you just start calling it in your Python code by writing from BAML client import B. And BAML client is something that gets auto-generated on every save whenever you save BAML files, or you can run a script to convert your BAML code into native Python code or TypeScript code or Java code, Ruby code, anything else you want. And then your autocomplete just starts working right after that.
Nice. Was DeepSeek added as support?
Yeah, so we support DeepSeek, so you can do function calling with DeepSeek if you want, which a lot of people have been doing because the DeepSeek models are really, really good. And then the Llama models, obviously, but I think we support any model. If you ever run into any bugs with setting up a model, then you should let me know because that is a huge bug. And we usually fix those pretty fast. So in this case, I'll swap it out to this one. And you can not only like see what the model is doing, but you're actually able to get a grasp of like, what is the sequence doing? And in this case, the sequence is actually like calling GPT-4 mini 3 times. And if that fails, it's going to call haiku because all of this is like encoded in the prompt as very programmatic declarative ways of accessing this data.
Nice.
So it hopefully should be very easy to get started. But the easiest way to get started so you don't actually have to learn all this syntax is go to boundaryml.com/chat. And then you don't even have to learn BAML. You just describe your problem like I did earlier with the math problem, and then you just get the results out.
Okay, and then you just copy and paste the BAML code.
Then you just copy and paste the BAML code locally, and you tweak it like we did today with the graph data where it was hallucinating. And that was a really interesting question that someone asked of like, how do you deal with this hallucination? We just update the data, and now we can update our UIs to go do something like that. And eventually, what you're able to build is something that's like BAML chat, but one more time, sorry. But you can turn your apps from, instead of, in this case, like a resume data, instead of your apps looking like this, you can build a pipeline that looks like this. And it just looks sexier. It has a lot more links attached to it. It's a lot more deeply integrated. In this case, I was maybe actually able to like even show an error that says, oh, this Twitter is not a valid URL, so don't click on this. But the rest of these are good. So it becomes easy for me to build trustable UIs with the user and like earn a lot of trust. Same with like a citation system. Where I'm actually able to like not just get the citation the model is dumping out, but build verifiability into my citations by saying not only does the citation actually map to what I have, but this citation does exist in the original context and it's backable. And in fact, in my UI, I can show you a link of exactly where it's backable and deep link you to it. So it just makes data models just make building things like this a lot easier and a lot more interactive. So same with like, I think you can build like a dynamically streaming graph visualization where you can even play around with the graph before it's fully done.
Yeah, that'd be nice to like kind of like verify the data
Exactly.
incoming data before you push it. Yeah,
exactly.
I like it. I see a future joint demo project coming down the pipe.
I think we should take what we should do is we should take the movie thing that I was hacking on together, and then build a UI on top of it and a way to add. Imagine in that demo, I could also add this movie to the database, and we leverage a new function that I wrote with the old database, and then we just like push data into it.
Oh yeah,
so we can also modify the database and read from it from the same chat agent. I think that'd be a really fun demo.
Yes, yeah, very easy to follow. There was I think someone posted a quick remark about the movies database in general, and it was something that actually I hear often. Where is he?
Oh yeah, I would pay real money to never see the movies graph database.
Oh yeah. I cannot find that chat here, but
yeah, John made a funny point on that. But I think the reason I like it is just it's so relatable for other people. But
yes,
it's like the weather API in tool calling usage. Everyone, whenever they show tool calling, is like get weather. That is the API call that we've all decided to show to everyone, and it's just not very interesting. I think.
Yeah, it's I hear this quite a bit, right? It comes up, but it's like, I think we're all open ears. Like, okay, well, what data set is easily relatable, and also like people have the internal knowledge to confirm whether the data that you're seeing is correct, right? Because a lot of us have seen movies, and so there seems to be few widely known common.
What do you think about people that tweet and GitHub repos?
Tweet GitHub repos,
like Twitter and GitHub, some sort of like interaction between Twitter and GitHub. I think that'd be so funny.
Like people's responses to GitHub, or like check out this GitHub.
Like there's obviously a lot of influencers that write code, and then there's also a lot of influencers that tweet a lot. And there's this really funny website that I saw that like shows you the ratio of code they write to the amount they tweet.
Oh.
I think that would be a funny graph database to play around with. Or that has quite interesting questions about that.
Yeah, no, I like that idea, right? Like anything revolving around GitHub, because all of us, developers here, like we all use it, and so we all can relate to that. So yes, as something for like non-developers that might be they'd be like, what
that would be like impossible for them to grasp. Like describing GitHub, there's so many weird relationships in GitHub that were hard to like describe.
But for developers, it would be great, right? Because we'd instantly kind of get it. Yeah, no, I like that idea. There might be something there. Yes. Oh, Titanic's data set was suggested by like the actual syncing with the crew and guest list. Is that what you're mentioning, Prasad? Let me just bring this up real quick. I remember this being recommended too. Yes, also a famous point in history, a little grim, but it's definitely some interesting data in there.
Do other people have any like live demos that they might want to see on the fly, where we can just try and build an agent in the last few minutes while we've all got some time together? And if not, I have a couple other ideas as well that I've shown around that might be interesting.
Well, I mean, Vaibhav, you can use the last few minutes. So how should people get in touch? I know there's a Discord channel for questions.
Yeah. So Discord is probably the easiest way to get in touch. I think one of the hardest things about building a dev tool that I've learned and now on the other side of it, actually building one rather than like using one, as developers are very, very hard to please. And honestly, as a developer, I had a negative value of my own time, because I'd rather build it than buy it or use something else. Because I remember when I first started, I did C++ my whole career, C++ and assembly. And like 4 years ago, for the first time, I had to make a website or something. And I refused to learn React. I don't know why. I was just like, this seems bloated. I'm not going to use React. And I literally invented my own version of React. I had state management. I had page routers. I built everything from scratch in JavaScript. No TypeScript, which is, again, a mistake. And eventually, I realized I was wrong. My framework wasn't bad, but it was definitely not React. It kind of sucked. What we try and do over at BAML is obviously we've made some design decisions. Some of them might be good, some of them might be bad. But really, we just try and learn from the community. So if any of you do try it, it means a lot to us, firstly. Like anyone just adopting a tool of any kind is a huge sign of, it's a nice way to tip your hat off to a developer, and it just means a lot to us, and we appreciate it. But if you do run into design choice that you feel like you disagree with, please just share the feedback. It helps us make BAML way better. A year ago, BAML didn't have syntax highlighting. It didn't have autocomplete. It didn't have F2 rename. And now we do. We didn't have test cases. We didn't even have the playground a year and a half ago. So it just takes time to build everything out. And like your feedback means a lot to us. So Discord would be amazing, or LinkedIn if you would like. But Discord is usually the easiest way to get in touch and get a faster reply.
Nice. And is there any roadmap or feature things that you're working on that you can tell people about that they should keep an eye out for?
In about 2 weeks, we will have something really new that I think very few people have ever seen, which is what happens when you build observability based off of knowledge of your type system.
Okay, let me copy and paste the Discord channel first, and then.
So once you build observability off of your type system, so like for example, you have an enum, you have a classification problem you're asking an LLM to solve, and you have 15 classes today. 3 months from now, you have 45 classes. We can help you automatically segment that data and build a training data set to train a fine-tuned BERT model off of it without you writing a single line of code.
Huh. Wait, did you send a link, or are you screen sharing something?
No, I'm not. I can't share that.
Okay.
I will soon. I will soon. But we're going to have some new capabilities that will take advantage of the BAML syntax and help you automate your almost update loop for your pipelines. And most importantly, help you gather the most important resource we all have in today's day, which is incredibly clean data. Like LLMs are great, but if we can't collect data off of them, it's almost useless. ChatGPT does something really interesting that I think very few people think about, which is every time they give you an answer, people obviously know they have the upvote, downvote button. I have never clicked on one of those in my life. People obviously know that they have side A, side B, pick one. And sometimes I pick one, but honestly, I just pick one. I read both, I get my answer, I'm just like, let me move on, and I just pick one. I don't really put that much thought into it. But there's another signal that they really take advantage of, and a lot of websites that are tracking really good data take advantage of, is your interaction. So if you copy and paste code out of ChatGPT, I can promise you they're collecting that data, because that is a source of truth. It doesn't matter what you clicked on. It's just like you copied and pasted that part of that code, and maybe not the whole message, but that part of it, I know that was correct. And I can highly, highly consider that to be good. And how do you collect that level of rich data? In the resume example I was showing earlier, how do I collect that? Hey, everything was good, but the Twitter link was bad. And exclude the Twitter link from my training data, but keep everything else the same. That's the magic. And I think that's what a lot of people need to be thinking about when they build these AI pipelines. So I think that'll be a fun thing to share on our roadmap in about a few weeks.
Nice. Okay. I'll have to keep an eye out for that. I got one last question. Forget the context. Extreme classification. Yeah,
we actually have a data set on our examples repo that shows you how to classify with 1,000+ classes. We've had multiple success scenarios around doing that, and it works really well with a model. But again, it's about bridging algorithms with models. So I can share the repo around that if that would be useful to people, of how we did it. I have it's called a classification problem. Where'd it go? I'll post it in private chat. There you go. That'll do it for you. And the trick there is actually a twofold trick. But I think it'll be useful to just, one more time. So the way you do build a classification problem is you have 1,000 classes, let's say, that are all in here. And we need to do two things. One, we all recognize that giving an LLM 1,000 classes is going to more likely lead to hallucinate and pick the wrong answer. So the first thing we have to do is we have to strip from these 1,000 classes down to 100 classes or 50 classes of some kind. And then we can take the user input and then combine that with an LLM of some kind, and feed these to get the actual output class. So like this is like, let's say like 100 category or like 50 categories. So the question then becomes like 1,000 categories. How do you convert from 1,000 categories down to 50 categories? So there's different ways you can do this. Some people use embedding, some people use GraphRag, some people use a variety of scenarios. So you can use any of those techniques to prune these down. And the example we use embeddings, but we do something a little bit clever with our embeddings. We don't just embed the 1,000 categories and pull them out. We attach metadata to every category and then use embedding model. Sorry. And I should make this a different color. We use an embedding model. So what we do is, what's actually going on is like this. And then we only take the top 50 that match this criteria. And we find that this technique works pretty well, where we just find the top 50 by cosine similarity. But the important part is this is R. And this is all software attach metadata. So like, what is metadata when it goes to each category? So the metadata can include things like usage of that category, previous examples, human annotated data about it, or just LLM generated data. We did all LLM generated data for all 1,000 categories and just had a human review it. And now we use that as our storage system. And where BAML comes in is BAML just makes this really easy to write, really easy to maintain, and also guarantees that the data models you get out are very, very fluid, very, very type safe, and guaranteed to be the exact of those 50 categories that you said, not just something that looks kind of like those 50 categories.
Nice.
So I don't know if this helps answer the question.
Well, if it doesn't, definitely reach out on Discord, or you can reach out to Vaibhav directly.
Yeah.
So, okay, so we're about at time. So thank you everyone for joining. If you want to catch us in real life, keep track of our socials, because Vaibhav and me we often do events up in Seattle every couple months. So I suspect we'll have another one brewing soon. And also for any other future joint content. Okay, all right. Thank you everyone. Thank you Vaibhav. Thank you so much for your time. This was awesome.
Thanks for having me, Jason.